and welcome to Tested. So in this series of videos, I'll be talking about programming for chemical engineers. And to introduce chemical engineers to programming, I have chosen the language Python. Python is a very simple language, and if you're starting to code, if you're starting programming, if you're getting a basic introduction to programming, then Python is actually a very good way to start your journey as a programmer because it's easy, it's relatively easy. And that is why you'll be able to understand the logic behind certain programs. You'll be able to think in uh, that manner. And then you'll be able to apply the logic, whatever you think, and you can basically you'll be able to uh, write it down in the form of a code. So to start applying your logic and implementing it in the form of a code, Python is a very good way to start with it. And once you get an idea of how to do this, then you can understand other languages. You can go to other languages, harder languages like C, Java, etc. But to start programming, to start get a basic introduction to programming, Python definitely helps you out a lot. And from here, you can slowly build upon and go and learn harder languages. So we'll be starting with Python. So the first step, of course, is to download Python. So you can download Python from the website python.org. I have also put the link in description. So you can go and download from there. It's free of cost. So once you download Python, you'll be able to open an environment like this by typing IDLE on your computer. So over here, for example, if I search IDLE, so it will give me IDLE over here. So you can type IDLE and you can open an environment like this. And after that, you can start working on Python. So yeah, when you open Python, a screen of this kind will open in front of you. And here, all your programs are going to get executed. Okay. So for example, if I say A is equal to 2, so over here, uh, after writing that, I have pressed an enter key. So now it has assigned this value 2 to the variable A. Okay. And now if I write A over here, then it will basically return the value of this variable A to me. Okay. So this is where your programs get executed. And yeah, that's what happens. So similarly, let's say I define another variable, let's say B, and I call it 3. So now I have two variables. I have A, which is 2, and I have B, which is 3. So now if I have to add those two, I can simply use A plus B, and it will give me the result as 5. And I can do other operations like A into B. So in programming, star implies you are multiplying something. So A multiplied by B is A star B. So that should basically give me 6 as the answer. And that's what I've got. Similarly, I can also divide A and B. And that has given me 2 by 3, which is 0.66. Now, over here, if you see this over here, this, all these are actually integers. But when I divide A and B, I get a decimal number. Okay. So the decimal numbers in programming, they are called floats. Okay. So this is basically a float variable. So if I store, let's say A by B in another variable C. So this C is actually a float variable. So A is an integer, B is an integer, but C is a float. So integer, float, all of these things are what we call as data types in Python. Okay. So data types are basically how a program or a computer interprets a particular number. So if I say that not just a number, but any set of data, how a computer would interpret it, that is what is called as a data type. So for example, if I say that, okay, if I say to a computer that, okay, I have A, the computer would interpret A as an integer. But if I say that, okay, I have a C, then the computer would interpret it as a float. All right. So yeah, these data types decide how much memory is being allocated to each and every variable in your program. So as we'll be going through in this lecture series, you'll learn more about these things. How much memory does each data type uh, take, and how to optimize memory. That is also another big part of programming. But yeah, all of that is not very important in the beginning while you're learning basics, because right now your focus is just to understand uh, how to build a particular logic. So yeah, I have A by B, which I can store in C, and C over here is a float variable. All right. So similarly, I can say A minus B, and that I have stored in another variable D. So now D is minus 1, right? So D is also an integer. Now I can also do something which is a double slash over here, and that has actually given me a 0. So this double slash, it actually just gives you the integral part of A by B. So A by B is actually 0.666. So A double slash B would be the integral part of A by B. That is the integral part of 0.666, which is just 0. So for example, if I write 100 double slash, let's say 40. So this is going to give me 2. The answer of 100 by 40 is 2.5. But since I have taken a double slash, so it would just give me an integral part. So that will just be 2. So that's very useful, because when you're wanting to store, let's say an integer, let's say you have said that, okay, this variable is supposed to store an integer. And then if you want an integer only, then in that case, using this operator is very useful. So if I, let's say, if I say that, okay, my C is supposed to be an integer, and I just want to store an integer there, so I can just use a double slash, which stores an integer in C, right? So all these things are very useful when you develop more programs, you'll realize that these operators come in handy a lot of times. So for now, yeah, this is an operator that you can use. Then apart from that, there is another operator, percent. Percent is actually what we call as modulo. Modulo operator is a remainder operator. So what it does is that if I write, let's say 5 modulo 2, so it will divide 5 by 2 and give me the remainder as an answer. So for example, 5 modulo 2 gives me a remainder of 1. Similarly, if I have to say, let's say 56 modulo 10, then if I divide 56 by 10, the remainder is 6. So it will give me 6 as the remainder. So this is another operator. So yeah, there are multiple such operators that you can use. A few of them I have introduced now. And as we write more programs, we'll find out about more of these operators, right? So once we are aware of these operators, let's now actually see that how to write it in a script, in a Python script. So what is a Python script? So basically over here, as you see, I am executing something and it is immediately giving me a result, right? At times I don't want that. I want to write all the set of commands all together and then execute them to finally get one result. Let's say I have stored a plus b in one variable, then I want to multiply that variable to another variable, and I have to do a huge set of operations, and finally I want one result. So for that, writing a Python script is actually very convenient. So you need to write a Python script. So in a Python script, you don't get these outputs together like this. Instead, those the output of that entire script comes all together at once. Okay. So in order to write a Python script, we have to go out of this uh, environment and we have to go into the environment where we are going to write the script, right? So we can go on file and write down and click on new file, or you can just use the shortcut control N. So when you do that, you get a script like this. So this is basically an untitled script. Now, as you see over here, unlike the shell that we were working on before, there are no these three arrows. They are not here. So basically here we'll be writing all the commands all together, and then we'll save this somewhere and run it. Okay. So that is very something which we would want to do. We would want to save our programs somewhere and then execute them. And over here in the shell, those programs cannot be stored. So if I close this shell and I open another time, open a shell another time, then all of this would get erased. We don't want that. So that is why we would be working on Python scripts. So yeah, we'll so this something like this would open up when you type Control N, and then over here we can write any program. Okay. So for example, over here I write a is equal to 2, which means I have given the value of 2 to the variable a. I write b equals to 3, which means I've given the value 3 to the variable b. And then I say c is equal to a plus b. I have stored the sum of these two variables in the variable c. And then I'll save this as, let's say, code 1. So now this script has been saved over here. And now I could just run this, right? I have I have saved this, and now I have to get the result, the output of this script. Okay. So first of all, let's just run this script and see what happens. Okay. So I can go and run, and I can run module from here. Or you could just press F5 on your keyboard. Okay. So I'll click on this, and the shell would open. And anything under this is the output of the code 1 that I have written over here. Okay. So as you see, nothing has been displayed over here. However, all the variables that I defined in my script have been stored. So I had defined three variables, A, B, and C. So if I type A over here, it will give me the value of A. If I type B over here, it will give me the value of B. And if I type C over here, it will give me the value of C. So these variables have been stored somewhere in the memory. And when I execute the script, I have basically run my program and I'll be able to get the result. Okay. So that's there. But let's say I don't want to type the names of these variables again and again. I want to make sure that the moment I execute this, I get these variables, the values of these variables on the screen. Okay. So that is what we call as the output of a program. Output is what we want to see when we execute our program. And to give an output, for a program to give an output, what I want is I want these variables. Let's say I want the value of a plus b. So I basically want c to be displayed the moment I run it. So for that, I use a statement called print. So what print basically does is print takes the variable and it prints it. Okay? It displays it on the shell. Okay. So if I save this and then run it, so now I'll get the value of c without actually typing c on the shell. Similarly, if I want other variables, let's say I want to print a and b, so I can type these statements over here and then I can run it. And now you see the first value I've got is for C because the first statement I executed for C. Then the next value was of A and then for B, right? Let's say now I want to switch the hierarchy. I want A first, B second, then C. So I'll just uh, print C later on and I'll get the same hierarchy as I typed. So now A has been printed first, then B, and then C. Okay. So yeah, this is how you get an output in a computer program. So now let's say I want to uh, execute a very complicated, not a very complicated, but yeah, a huge mathematical operation where I want to add the two of them, A and B, then multiply the sum with C and then add 15 to it. And then I want to display the output, right? So one thing I can do is I can make another variable B. I can add the two of them, A plus B. I can multiply it by C and then add 5 to it. And then finally print D, which is going to give me the result as this. But let's say I don't want to store this value in another variable. I just want to print the result of the operation. Although that's not always the case that we do. But let's say I don't want another variable d to store this value, right? So what I can do is I can, in place of d, I can just write down the entire thing. This operation I'll write over here and I'll remove this variable d altogether. So if I do that and run, I'll get the same answer, right? So that is another thing that Python can actually do. You just print the operation that you want to do, and without storing it into another variable, it just gives you the result. Although that's not what something that we do multiple times, but yeah, it's fine to do once in a while. Okay, so fine, we have the three variables A, B, and C, and we can perform multiple operations with them. We can display the output of these operations, right? Now, let's solve a simple chemical engineering problem through this particular method, right? Whatever we have learned so far, let's just try to implement that. So the chemical engineering problem that we'll be solving, not exactly a chemical engineering problem, but yeah, a very basic problem, we'll be calculating the molecular weight of a hydrocarbon. Okay. So before that, uh, so I'll introduce you to something else. So that is known as comments in Python or comments in any programming language. So comments in a programming language are basically some statements that you mention and that you don't want the computer to read those statements. They are for your own good, that they are for your own understanding. So this hash means you're starting a comment in Python. Okay. So if I write A, B, C, something like that over here, then the computer would not actually read this line and it would execute this program without any issue. However, if I remove this hashtag from here and then I run this, then it will show me an error, right? So a hash is used when you want to add comment in a particular program. All right. So that's there. So I have to calculate the molecular weight of a hydrocarbon. So a hydrocarbon contains only hydrogen and carbon, right? So let's define a variable MH, which is a molecular weight of hydrogen, which is 1 gram per mole, right? And let's say MC is for molecular weight of carbon, which is 12 grams per mole. Okay. And now let's describe another variable, NC, for the number of carbon atoms in the hydrocarbon. So let's say we are finding out the molecular weight of, let's say, methane. So methane has 1 carbon atom and 4 hydrogen atoms. So NC is number of carbon atoms in methane, okay, and NH is another variable, which is the number of carbon atoms in, number of hydrogen atoms in methane, right? Now, how would you calculate manually the molecular weight of methane? You would multiply the number of carbon atoms to the molecular weight of carbon, atomic weight of carbon, and you'll multiply the number of hydrogen atoms to the atomic weight of hydrogen, right? So we'll do the exact same thing on computer. So we'll define another variable MWT, and what we'll do is we'll multiply the number of carbon atoms to the atomic weight of carbon, right? And then add it to the product of number of hydrogen atoms and the atomic weight of hydrogen, right? This, the code till here, would calculate the molecular weight of the hydrocarbon methane, right? But now we need to display this particular molecular weight on the shell. We want that as soon as the program gets executed, this molecular weight should be displayed. So for that, we use the print statement. So I'll display the molecular weight and then I'll save it and then I'll run it. And as I run it, the molecular weight of methane is displayed on the screen. And now this makes it very easy for you to calculate the molecular weight of any hydrocarbon. Let's say I want to calculate the molecular weight of, say, pentene. So we know that in pentene we have 5 carbons and 10 hydrogens. So we will just change the value of this variable. I'll make NC equal to 5 and NH equals to 10, and I'll execute this and I'll get the molecular weight of pentene. Let's say I want to calculate the molecular weight of benzene. So it's C6H6, and over here I change that, and based on that I'll get the molecular weight of benzene, right? Things like these can be done easily using Python. All this you can do manually using a calculator. But now the objective of this series of videos is that you know how to do these things using a program, because these small programs will make up a very big program that would ease your calculations quickly, ease your calculations to a great extent. So yeah, I hope you could understand whatever was there in this video. I'll put the link of the python.org site from where you can download Python in description. I'll also upload these programs that I'm writing for each video uh, in a Google Drive link, and I'll give the Google Drive link over there in description as well. So you can access these programs and run them on your computers. And you can also manipulate these programs for your own use. For example, if you want to calculate the molecular weight of any hydrocarbon, you just need to change NC and NH and you'll get the molecular weight. So yeah, you can use these programs for your own purposes as well. So that's all for today's video. Thank you.